All right, so our next speaker's first tech conference was a speaker at Lambda, and it turns out to be a really life-changing experience for her. So now she's back on the stage. So she's here for her talk on the rise of reasoning models. Please welcome Valentina Halasi.
Thank you. Welcome, everyone. Thank you for coming to my talk about the rise of reasoning models. My name is Valentina Halasi. Originally, I'm a mathematician, but I co-founded an early-stage startup together with Max. It's called Storic, and I'm developer and co-founder of Storic right now. It's a multimodal tool for the creation of personalized storybooks with AI-generated custom illustrations backed by a team of AI agents and, as I said, custom diffusion models. Last year, maybe some of you attended my talk about Storic. I shared my journey, our journey about building this product, and I focused mostly on image generation. But this time, I'm going to be talking about something else. Because just like many multimodal softwares, like Storic, are backed by reasoning models. They play a very important role in this tool as well, because they can handle the most complex tasks. And this is why I think that reasoning models are at the forefront of AI innovation. And we are focusing on them today also because we are used to that new high-performance LLMs come out each week, but the reaction of the users and the developers is muted. So if it comes to conventional LLMs, we are used to the fascinating performance of them, but they are not enough interesting anymore to hit the headlines. Unlike reasoning models, because the real excitement today is around models mastering problem solving, especially mathematical problem solving, decision making, and those multimodal softwares which are able to handle complex tasks. We don't necessarily need reasoning models for handling such tasks. We can also simulate reasoning in conventional LLMs. I listed down 4 techniques for this. The first 2 are just prompting techniques, chain of thought prompting, which you surely heard about. So we just show with guided prompts how we wish the LLM to answer. And the other one, which is also a prompting technique, is called React. And it's about combining reasoning and external actions in an interactive loop and giving an LLM an example how we wish that it answers our a bit more complex question. It delivers the answer in this style. Well, the other 2 techniques. First one is agent frameworks. It just treats the LLM as a part of a bigger decision-making problem. And I'm not going to dive into detail because my co-founder, Max, is going to give a talk after my talk, and it's going to be very interesting, focusing on AI agents. Highly recommend you to say. And also the 4th one is tool use, when we make tools available for LLMs, which are capable of solving problems in a deterministic way, like calculators or APIs. But today, we care about real reasoning models. They are LLMs explicitly designed to perform multi-step problem solving. Both the thinking and the answer is a step-by-step process, just a chain of thoughts. And during this talk, we will look into how they are actually designed and how you can further enhance those models. But let's first talk about when exactly to use reasoning models. So the OpenAI documentation says you should treat them as reasoning models as a senior coworker, and the conventional LLMs as a junior coworker. So the junior coworker is able to give you, or the LLM is able to give you quick answers for low cost. And if you really well define a task, it's going to be reliable for solving that task. But if you want very complex problems to be solved, you are going to need those special LLMs. It's also important to use them properly. Even if chain of thought is a technique to evoke reasoning in normal LLMs, you should not use it if using reasoning LLMs, because it just lowers its performance. And also, zero-shot prompting is recommended if using reasoning LLMs to enhance their performance. I'm going to be focusing on two tools during this talk. Two family of models, the OpenAI reasoning models and the DeepSeek reasoning models. They are head-to-head in terms of performance. Even if we see these 6 benchmarks, their performance is very similar. But there is an important difference between them. So in terms of their APIs, using the DeepSeek models is much more affordable, and they are also open source. Also, what is great that DeepSeek published a very good detailed technical report providing details about how those models architect looks like. While in terms of the OpenAI models, we can only suspect, the researchers only suspect how they are built up. So I'm going to be focusing on the DeepSeek model because we actually know how they are built up. So let's see how reasoning models are built. There are basically two families of methods. Either we can do model training or we can scale its inference time. Let's see now inference time scaling first. These methods are not always part of the LLMs. They are often built up on the application layer only. And those two techniques, prompting techniques, which I already mentioned, can be already considered as inference time scaling methods. So let's see a bit more complex and sophisticated methods. For example, if we ask the LLM to provide multiple answers, or we provide the LLM for the same question different prompts, and we get answers for them, we can use some kind of verifier or voting to pick the favorite answer out of those different options. And also more sophisticated models are search strategies. For example, stochastic beam search. And this method is about generating each reasoning step in a fashion that we don't only save the most probable next token, but also different options. So the LLM can re-evaluate them with its self-evaluating score, and it can spend a bit more time and more test time to think about if those solutions lead to an actual good answer, and it just spends a bit more time on thinking. And researchers suspect that OpenAI models actually use such sophisticated test time scaling methods because their usage is just more expensive. So the application of reinforcement learning methods brought a real breakthrough in reasoning models. Reinforcement learning is about optimizing the LLM's behavior via maximizing some kind of reward. This reward can be some model trained by human feedback, or it can also be a deterministic method like a calculator. And with these rewards, we can direct the LLM to enhance its problem-solving skills. And the DeepSeek R1 model was enhanced by pure reinforcement learning. And it was a very interesting point of DeepSeek research, because they realized just with reinforcement learning, the model learns the style, the reasoning style, and the model starts to question itself and use reevaluation to refine its answers. And this DeepSeek R1 didn't even need an explanation about what reasoning is and how a problem could be solved as a chain of thoughts, but it just evoked its reasoning skills naturally. So I think that's the most exciting part of reasoning model research, how far these pure reinforcement learning can get those models. But according to the DeepSeek R1's technical report, this technique resulted not perfect reasoning skills, because the answers had a bit poor readability, and also it mixed languages. So they realized some cold start data is needed, which we can achieve with supervised fine-tuning. It's the most common approach in today's reasoning models to combine these two techniques. Supervised fine-tuning, probably everyone knows, is just about teaching reasoning patterns explicitly to an LLM as a pre-training step. And on these two images, you can see that either we train a supervised model, a supervised policy, or we can train a reward model with supervised fine-tuning for later reinforcement learning. Also, supervised fine-tuning is the technique how small reasoning models are created, because we can take any small LLM and perform supervised fine-tuning on it with data provided by a larger reasoning model in a reasoning style data set. So we can ask this question: if we have a given limited resource for computing, what gives us better results? If we take a larger pre-trained model, or if we take a smaller model and just enhance this test time computation? Well, we can suppose for this theoretical question that actually the querying costs the same, but it's not true, because it's going to obviously cost more for the larger model. But who thinks that pre-training gives better results? And who thinks that enhancing test time computation? Yeah, everyone is right. Because actually it depends on the problem. So researchers found that if it's a very complex problem, the most complex problems are efficiently solved with a pre-trained model, while if we have a less complex problem, or even a very easy one, enhancing test time computation of a very small model can bring the same results, the same good answers as a larger reasoning model, which is even 14 times bigger. So it's important to pick the right model for the right task. How can we further evolve reasoning models? We already discussed that these models are great for mathematical problem solving, logical problems, but let's make them good for also other domains like law or politics. And there is a method called argumentative querying, which make the model focus on better arguments before providing an actual answer. So we just encourage the model to bring up different arguments and analyze them. And according to researchers from London, this brought great results for problems in law or politics, as I said. So yeah, we give the LLM actually chance to reevaluate and find their own mistakes. Another interesting method is journey learning. It just encourages the model not to learn just the shortcuts, but the whole thinking process. It's a type of supervised fine-tuning when we don't only give a path to a right solution, but also paths to wrong solutions. So researchers from China try to mimic or try to analyze or think about what could be the reason why OpenAI models are so efficient. And they assume that journey learning could be one of the methods they used while building their models. And I already mentioned, but I would like to emphasize tool use because it's very important, if available, to give deterministic tools to LLMs to reduce the chance of their mistakes due to their probabilistic nature. So if we implement decision logic for tool use and we bound those LLMs or reasoning models to follow those exact rules, we can reduce their freedom and enhance the performance of our own software. So as we have seen, all of those techniques try to focus on one direction, to make the model argue, learn from its mistakes, and to use deterministic tools to reduce the chance of mistakes. Make sure to use the right model for the right task in order to save computing. And also, if you can, try to define a strict framework for your software when using AI in order to minimize errors and improve its predictions. Thank you so much.
Thanks, Valentina. Do we have any questions for her? Yeah.
Yes.
Hold on, let me get the mic over to you.
It might not be the smartest question, but I will ask anyway. What model should choose the model?
What model should choose a model?
Yeah, so you said we should choose the right model for the right job. Is a model should choose a model?
Not necessarily. I will choose the model myself, analyzing the problem I want to use, and think about those techniques I listed up, and maybe combine them within a framework of AI agents. But it's a very general question. I would not ask a model to choose the models, but yeah, analyze it myself. Yeah, using multiple models. Yeah. Yeah.
Any other questions? Yeah.
So what other weird use cases, so you mentioned politics, you mentioned some other things. Obviously, I feel like the majority, there's going to be a bunch of fields and ways to use AI models that we haven't even thought of yet. Are there any weird ones where you're like, hey, these reasoning models, nobody's thought of this niche yet? Are there any curious ones where you're like, oh, that's probably going to get used there once we actually scale this up and more people are implementing it generally? Or do you think that have we explored every like field? Are there any interesting fields to apply these reasoning models to, in your opinion, that are underutilized right now, or no?
Let me see.
If not, it's fine. I guess that's the whole point. If we don't know, then maybe it's just a bad question.
It's just a matter of creativity. So who is more creative than me? Yeah.
One fun example would be that researchers at Google, they started developing this small JAMA model, which is specifically trained to understand and communicate with dolphins.
Oh.
So I think this is quite a creative use case, yeah.
Well, that I would love to use also. Communicating with cats and dogs, I think that's going to be doable, feasible within a short time. If I had lots of time, I would try to hack something. Yeah.
Did we have any other quick questions? Go ahead. Yeah.
So to kind of go off the first question, how do you evaluate a model? Meaning, which model should I choose? I have a problem. How would you go through that process of selecting?
Mm-hmm. Well, I'm a very theoretical person, so I would read the papers in the field or in that specific area of models. I would just ask an LLM to write a lot of use cases, problems to solve to the model, and also another one to evaluate them, their performance, and I would just use statistics to scale the space of problems and hoping to be lucky.
So maybe create some test cases, if you will, send them to the LLM, see what their response is, and then kind of evaluate several on the same basis.
And building a framework for actually evaluating the performance of different models on those problem sets. Yeah.
You got a follow-up?
Are there any benchmarks? Because it sounded like maybe you do your own. Are there any popular benchmarks that normal people that aren't you that we could use to benchmark these tools? So I know there's some big ones. There's I forget what it's called. It's the one where Grok was hiding at it. It was called Choco for 3 months, and they were just pretending it wasn't Grok. But are there any ways you could point us to that you're aware of, big AI benchmarks where we could test the reasoning models? Or because it sounds like you're so good about it, you actually do it yourself a little bit.
Thank you. Well, I will really rely on the mathematical benchmarks because those are the most exciting for me. Because And
if I Googled that, they would they'd pop up that would pop up. I could see which ones those are.
Sorry.
So are those widely accessible ones where maybe you
yes.
I think you might have gone. Yeah, exactly.
This Mod 500.
Well, then I'll take a picture of your slide. Thank you.
Yeah, it's from the DeepSeek technical report.
Okay.
Yes. Most of them have have them a screenshot or a link, but this one does not have. It's from the DeepSeek technical report.
All right, well, it looks like we're out of time, but those were a lot of great questions.
Thanks,
Thanks,
you so much.
Valentina.
Thank you.